everyone, welcome to Vijay Chemistry. Today we are going to discuss about the main group element lecture 9. In the today lecture we are going to discuss about what? Multi-center bonding. Please note, it's a very important topic for what? JAM. Please note, it's the most important topic. The most important topic for our JAM exam. Okay. Now, before I'm going to explain the multi-center, now I'm going to discuss about what is a covalent bond. Okay, what is a general covalent bond? What is the difference between general covalent bond? What is a multi-center bond? First, I'm going to discuss that part. Then I go for what? Examples. Okay, please note, general covalent bond involve the two orbitals. How many orbital? Involve two orbitals. It means what? The two center. The common example, please note, the most common covalent bond, covalent bond, that is two center, two electron bond. The center, C means center, E means okay. The two center, two electron. What is the example? Hydrogen. I take hydrogen and hydrogen. How many center? What does mean center mean? Number of atoms. Therefore, one hydrogen, two hydrogen, and two. This is what? The common covalent bond. Now, very important. This is what is the minimum covalent bond? This is minimum covalent bond. Nothing but what? The two centered and one electron bond. For example, H2 plus. How to write H2 plus? Hydrogen. Here also hydrogen. I put only one electron, right? This H plus. This bond is nothing but what? This bond nothing but what? This bond nothing but the two center, two hydrogen, two center, one electron bond. And this bond should be what? The two center, two. Okay. This is the most common bond. Whenever the covalent bond, what is the covalent bond condition? The two center, the two electron bond. This is a common covalent bond. This is a minimum covalent bond. Okay. Now, what is a multi-center bond? Please note. Now, we're going to discuss what is multi-center bond. Please note. The multi-center bond. Okay. Now, see. First, I give the definition. Please know the definition. Very important. Here. More than two atomic orbitals. Two orbitals are involved in bonding. Okay, orbitals. Listen, only two orbital involved, that is common covalent bond. Okay, more than two orbitals, that is called what? The multi-center bonding. What is the example? Common example: the three center, two electron bond, and three center, four electron bond, and the four center, three electron bond, and the four center, two electron bond. Okay, these are what? The common multi-center bond. In this four, this two is very important. Please note, this is the most common. This is what? The most common multi-center bond. This is most common. This two, okay? This two. This is most common multi-center bond. Okay. Today class I'm going to discuss about what? The three center, two electron bond, and three center and four electron bond. Okay. First I'm going to discuss what is a three center, two electron bond, then followed by what? The three center, four electron. What is the best example for three center, two electron? Diborane. What is the best example for three center, four electron? Al2Cl6. Okay. Let's I start with the diborane. I finish with what? Al2Cl6. Okay. Now let's start. Please note. First example. First example. That is diborane. What is the formula? Diborane. B2H6. This is diborane. Okay. Now see. Very important point. Now BS3. Okay. What is the total valence electron? The total valence electron is equal to boron belongs to 13 group, therefore 3 valence electron. Hydrogen is 1 electron, 3 hydrogen, 3 electron. Therefore, how many electron? 6 electron, right? Therefore, this is electron deficiency. Now, this BF3 undergo what? Dimerization. BH3 undergo what? Dimerization. dimerization, I get what? I get B2H6. This is called diborane. This is diborane. Now, we know very well, right? Boron, atomic number 5. Configuration 1s2 and 2s2 and 2p1. This is what? Ground state, outermost and ground state, right? Now, this is 2s2. This is 2s2. This is 2p1. 2p1. This is ground state, right? This is ground state configuration. What is excited state? This certain go to what? Vacant orbital, right? Therefore, this is 1 electron. Now, this is what? In this case, 1, 2, 3. Now, total how much? Total sp3, right? In sp3, okay, s orbital 1 electron, p la வந்து 2 filled 1 adu. This is empty one. Okay, this is empty. But total how much orbital? How many orbital? sp3, okay? I mean 1s orbital and p. sp3 combination will be there. Now, I'm going to explain what is a bonding in what? Diagram. Very important. Please note. Now, you know hydrogen configuration? 1. 1s, 1, right? Only 1 electron outermost. Now, see the bonding. See, this is boron, right? Boron. Here also boron. Now, what is hybridization? sp3, right? Therefore, I put 1 and 2 and 3 and 4, sp3. Similarly, this one, 1 and 2 and 3 and 4, right? Now, how many valence electron will there? 3 valence electron, right? 1, 2, 3 valence electron. Therefore, I put what? Here 1 electron, here 1 electron, here 1 electron. But in this case also 3. Here 1 electron, here 1 electron, here 1. Now, hydrogen make a bond, right? Now, make hydrogen. Here hydrogen atom. Here 1 electron bonding. Here hydrogen atom. What? 1 electron bonding. Okay. Similarly, here hydrogen atom. 1 electron bonding. Here hydrogen atom. 1 electron bonding. Now, this hydrogen, this hydrogen, this hydrogen. Now, this. Now, see, boron and hydrogen. 2 center. How many? This is what? The 2 center 2 electron, right? Because the 2 or boron, 1 hydrogen between 2 electron, right? Therefore, this also what? The 2 center 2 electron. This also same, right? 2 center 2 electron bond. This also 2 center 2 electron. 2 electron. Now, see the hydrogen atom. Here 1 hydrogen, right? 1 hydrogen atom. I have 1 electron. Here hydrogen atom 1 electron. Now, what will happen? Listen. This 1 hydrogen atom, what will happen? Going to what? Going to delocalize to this boron as well as this boron. Similarly, this 1 electron delocalize to what? This boron atom to this boron atom. Therefore, this bond nothing but what? The delocalization will take place. What delocalization? This 1 electron go for this boron orbital, this boron orbital. Okay, simultaneous what? The electron transfer to what? 2 boron atom. What is the resultant diagram? See, this is a resultant one. I write this like, please know, very important. It's a resultant one. This type of bond will take place. This hydrogen bond. Okay, hydrogen electrons. Similarly, this is hydrogen electron. Understand? About this hydrogen, this hydrogen. Now, if in this case, boron, hydrogen, boron, how many electron? 3 center, only 2 electron. Therefore, this is what? The 3 center 2 electron. This also what? The 3 center 2 electron. Therefore, the 3 center 2 electron, it is known as what? It is known as multi-center bond. Yes or no? This is called as multi-center bond. Understand? What is the total result in this case? In this case, 1, 2, 3, 4 terminal, right? The 4 terminal. Then this is bridge, okay? This is bridge. Therefore, how many bridge? 2 bridge at 2 bridge. The 4 terminal should be what? The 2 center 2 electron, and 2 bridges should be what? The 3 center 4 electron bond. Understand? This 3 center 2 electron bond, this is known as what? Electron deficiency. This is known as electron deficiency. Understand? Very important. Please note. Okay. Now I give you the what? This is an orbital diagram. Please note. This is an orbital diagram. Orbital diagram for B2H6. Okay. Please note. Very important. Okay. Next I'm going to discuss what is a bond length, what is a bond order. That fact I'm going to discuss next slide. Now see. Now this is boron, right? This is boron atom. Here also boron. Here 1 hydrogen, here hydrogen, right? Here also hydrogen. Now this is hydrogen. In this hydrogen, this is diboron, right? Hydrogen, dihydrogen. Now you know very well, right? Listen, this bond nothing but 2 electron, right? This also 2 electron. This also 2 electron. This also 2 electron. Now, for in this case, what? Total 2 electron. Therefore, I put half electron. Here also half electron. I put half electron and half electron. Understand? Okay. Simple one. Now see. Now this one, I go and write this like also, right? See the structure. Boron. Here boron. Okay. Boron and boron. Now I go and write this like. Because this hydrogen electron density what? Delocalized to what? 2 boron atom, right? I can draw this like. Here hydrogen and hydrogen and hydrogen and hydrogen and hydrogen. This bond is known as this bond. This is called delocalized bond. Delocalized bond, right? First name. What is second name? This is called as banana bond. Very important. Like a banana shape. It's a banana bond. Banana bond is also called as tau bond. Tau bond. Okay. The three name. Okay. This is delocalized bond and also banana bond. Also, what is the other name you know? Common name. That is 3 center 2 electron bond. We can call 3 names. Okay. One is delocalized bond. The property is delocalization. Okay. Delocalization property and banana bond delocalization property. Okay. Delocalization property. Then banana bond because of banana shape. Banana bond and tau bond are also 3 center the 2 electron bond. Understand? See. Now what is the bond order for this molecule? Bond order. What is bond order? You know, bond between 2 atoms, right? This bond order. Now how many bond between this boron hydrogen? Therefore bond order is 1. For in this case, the bond order is 1 BO. In this case also bond order is equal to 1. In this case also bond order equal to 1. This case also bond order equal to 1. For in this case half only, right? Bond order is equal to half. In this case bond order equal to half. In this case bond order equal to half. In this case also bond order equal to half. Therefore, what is the total bond order? See, the total bond order 1, 2, 3, 4, right? 4. Then this is what? 1, 1, 2, right? Plus 2. What is the answer? Answer is 6. The total bond order of a diboron answer. What is the answer? Answer is 6. Okay. This way you can find out the bond order. Please know this is bond order calculation. Bond order calculation. Next, I'm going to discuss what is a bond length, what is a bond angle. First, I go and discuss bond angle, then go for what? Bond length. Okay. Bond angle is very, very important. Please note. What the bond angle of diboron. Very important. The bond angle of diboron. See, very simple. Based on electron, we can find a bond order, right? Now here boron. Okay. Here hydrogen atom. Here also boron. Here hydrogen. Here hydrogen. Here hydrogen. Here hydrogen. Here hydrogen. Okay, listen. Now what is the total electron? Here 2 electron, right? Here 2 electron. Here also 2 electron. Here also 2 electron. Here also 2 electron. Here 1 electron. Here 1 electron. Here 1 electron. Here 1 electron, right? Now see, this is alpha 1. This is alpha 1 angle. This is alpha 2. This is alpha 3. Okay. Now, which is higher bond angle? Please note. Bond angle. Very important property. Bond angle. Now you know very well, right? The number of electron increases. Number of electron increases. Repulsion increases, right? Electron repulsion increases. Electron repulsion increases. Therefore, what will happen? The bond angle also increases. Bond angle also increases. Therefore, in this case, 4 electron. In this case, what? The 4 electron involved, right? 4 electron. But in this case, 3 electron involved. But in this case, only what? The 2 electron involved, right? Therefore, what is the bond angle? Which is higher the bond angle? Please note. Bond angle. Your bond angle. It should be what? Alpha 1 is higher. Then see alpha 3 lower, right? Because only this is 3 electron, 2 electron only, right? Therefore, here alpha 3, right? Then alpha 2. Understand? Because listen, alpha 2 only 2 electron, only 2 electron in this involved. In this alpha 3, 2 plus 1, 3 electron. Now alpha 1, 4 electron, therefore, which is higher the bond angle. Alpha 1 is higher the bond angle, then followed by alpha 3, which is lesser the bond angle, alpha 2. This alpha 2 is internal bond angle, the alpha 1 is outer bond angle, this is also outer bond angle. Okay. Now, what is the experimental value? Please note. The experimental value bond angle, the experimental bond angle, experimental bond angle. Very important. They ask an exam. Bond angle of diborane. Okay. I give you the structure. See. Very simple. Here boron. Same structure only. Here hydrogen. Here also boron. Inga hydrogen. Right? Up inga hydrogen. It's diborane structure, right? Here hydrogen and hydrogen. Now see. This is alpha 2 value. Listen. The alpha 2 value around what? Around 97. This alpha 1 value around what? 122 degree. Okay. This is value. Okay. This is very important. Alpha 1 is nothing but what? 122 degree. And alpha 2 nothing but what? 97. What is alpha 3? Is in between what? Is in between alpha 1 and alpha 2. Okay. Alpha 2. Very simple. Okay. This 2 is very important. Okay. This bond angle and this bond angle is very, very important for what? For exam point of view. Now understand. Now we understand what is the orbital diagram. Yes, what is the total bond order? Then how to calculate the bond angle for diborane. Next target, I'm going to discuss about what? Bond length, which is higher the bond length, which is the most strengthened bond. I'm going to discuss about what is the bond parameter for diborane. Please note. And next concept, this is nothing but what? The bond length. Very important. Bond length. Now, in generally, first I give you the order. Please note. In general, okay, the bond strength, which is most strong bond, always sigma bond, then tau. What is tau bond? Banana bond. This is tau bond. Then followed by pi bond. Okay, listen, the tau bond is also one type of sigma bond only, but compared to sigma bond is weaker. Okay, this is called as what? Tau bond, banana bond. This is banana bond. Also called as what? We call this 3-center 2-electron bond. Okay. Now, in case of diborane, which type of bond is present? Sigma bond is present and tau bond is present, right? Now I get boron, here hydrogen, here also hydrogen, boron, here hydrogen, this is hydrogen, this is also hydrogen, here hydrogen, here what? Boron. Now note, this is A, take is A. Okay, this is A, this is B. Which is the bond length? I go to bond length. Very important. Bond length is very important. Now you know very well, right? The bond strength increases. Bond strength increases. Bond length decreases. Therefore, which is stronger bond compared to sigma tau, which is stronger bond? Sigma bond is more stronger bond. Therefore, which is lower the bond length? The sigma bond is lower the bond length, and the bridge is tau bond is what is tau bond? Bridge bond. This is bridge bond. Also called as what? Banana bond. Banana bond always what? Higher the bond length. Okay. Now experimental value. The experimental value. What is the value? The A, nothing bridge, right? This is bridge 1. Bridge. What is the bond angle? It's around 131 picometer. Now this is B, terminal 1, right? Terminal. Okay, sorry. B is bridge. Okay, B is bridge, right? B is bridge 1. Please note. This is B. This is A, right? A is a terminal, right? Please note. Now this is A. This is A. This is terminal bond. Nothing but what? Nothing but around 119 picometer. Understand? Therefore, this bond angle nothing but what? B. Nothing but what? 137 picometer. And this bond angle nothing but what? This bond angle nothing but 1119 picometer. Okay. This is about what? Diborane. Very simple. Okay. First you have to know what is the diborane formula. Then you have to understand what is the orbital diagram. Then what is the bond order? What is the bond angle? What is the bond length? Okay. Now you know which is higher the bond length? The bridge bond. The bridged bond is higher compared to what? Terminal bond. Terminal bond. Understand? Now I'm going to discuss about what? Al2Cl6. It's also what? Multi-centered bond. And second molecule, second example. Please note. Very important. That is also what? Al2Cl6. Very important one. Now, similarly, okay, similar to BH3. Now I take AlCl3. Now what is a total valence electron? Similar, right? Total valence electron. This belongs to boron family. There are 3 valence electron. This is 3, right? Therefore, I get what? 6. This is also electron deficiency. Electron deficiency. Therefore, they undergo what? Undergo dimerization. Dimerization. I get what? I get Al2Cl6. Right? Now write the configuration aluminum. Aluminum. What is the configuration? Outermost configuration. That is 3s2 and 3p1. This is 3s2, right? This is 3s2. This is 3p1. This is a ground state. Similarly, this is a ground state. Now, what is the excited state? Nothing but 1 electron shifted to our vacant orbital, right? Therefore, this excited state. Here, 1. Then how many? What is value? This is sp3, right? Again, same to boron. But in this case, chlorine, right? On B2H6, hydrogen only 1 electron, but chlorine, yeah, they belong to p block element, right? Therefore, in case of Cl, chlorine, what is outermost configuration? Also, the 3s2 and 3p5, right? Therefore, I write on this electron. Now 1, here also 1, 2, 1, 2, 3, 4, 5. This also sp3, right? Understand? Now I am going to explain what is a bonding nature, the orbital diagram for what? Al2Cl6, then followed by what? The overlapping. See, in case of AlCl6 is aluminum, same case. Here also aluminum. Now this sp3, right? Therefore 4 orbital, 4 lobes. 1, 2, 3, 4 lobes. Similarly 4 lobes. Okay. Right here. Similar this one, 1 and 2 and 3 and 4. How many valence electron? 3 valence electron. Therefore, here 1, here 2 and 3. So here 1, here 2, here 3. Similarly, take for sigma bond, chlorine atom, right? This is chlorine sigma bond. This is chlorine Cl. This is chlorine sigma bond. Okay, Cl. This is chlorine sigma bond Cl. This is chlorine sigma bond Cl. Now see, this is aluminum Cl. Therefore, what? The 2 atom 2. Therefore, this is 2 center 2 electron bond, right? This also 2 center 2 electron bond. This also what? The 2 center 2 electron bond. This also what? The 2 center 2 electron. Now, in case of Cl, very important, please note property. In Cl atom, in Cl also sp3, right? 4 lobes, right? 1, 2 and 3 and 4. So this Cl. Also what? 1, 2 and 3 and 4. Now in case of Cl, look the electron configuration. Only 1 unpair, right? All the 3 electron paired. Therefore, this 1 electron can make what? Single bond, right? I mean mutual charging. This lone pair able to what? Give the complete charging, right? Therefore, in case of bridged atom, please understand very important point. In case of bridged atom containing the lone pair, able to make what? The coordinate covalent bond to central atom. This is a very important property. Therefore, this 1 electron, they make what? They make a bond, right? So this bond. Now, it containing what? The 2 electron, right? This 2 electron. This also 2 electron. Because lone pair, they make what? They make you the bond with this vacant orbital. Understand? Okay. Now give the proper diagram for understanding. Please know the diagram. Here, same. Here aluminum. Okay. Here also aluminum. Here 4 lobes, right? 1, 2 and 3 and 4. Similarly, here 1, here 2, here 3, here 4. In Cl atom, see. In Cl atom, you make what? Here 1, here 2, here 3 and 4. Inside a Cl atom, here 1, here 2, here 3, here 4. Now put the electrons count. We know right here 1 electron and 1 electron. In this case, what? This 1 electron, 1 electron charge. In this case, this 1 electron, 1 electron. In this case, what? The 2 electron give us this 2 electron completely from chlorine atom. This 2 electron comes from chlorine atom. Okay. What will happen? The chlorine atom give the 2 electron complete to what? The vacant of aluminum atom. Vacant orbital aluminum atom, right? This also. Now, for in this case, this is 1 electron. Okay, 1 electron. For in this case, here Cl atom. Here also Cl atom. Here also Cl atom. Here also Cl atom. Okay. You put 1 electron here. 1 electron. Outermost electron. 1 electron and 1 electron. Okay. Now see. Now look the bridge bond. Very important. Look the bridge bond. Very important. If you look at this bond, okay, this bonding, How many center? Aluminium, Cl, aluminium, right? Therefore, 3 center. Understand? How many electron involved? 1, 2, 3, 4. Therefore, this is 3 center, the 4 electron bond. Very, very, very important. Understand? How 4 electron can happen? Because chlorine having what? 1 unpaired electron, also 3 lone pair. Right? One of the lone pair give what? Completely give what? Electron to the vacant orbital of aluminum atom. Okay. In case of Al2Cl6, which bonding can take place? The 3 center, 4 electron bond. Therefore, in case of Al2Cl6, the 1, 2, 3, 4 terminal bond. The 4 terminal. Which bonding? It should be the 2 center, 2 electron, right? 2 center, 2 electron. And in case of 2 bridge bond, 2 bridged bond. Bridged. Which electron? This is 3 center, 4 electron bond. Understand? This is what? This is called as the orbital diagram of Al2Cl6. Okay, please, very, very important. Okay, next I'm going to give what? Normal diagram, normal bond diagram. See, simple one. Here aluminium, same. Here aluminium, here also aluminium, right? Here chlorine, here chlorine, here chlorine, here chlorine. Now similar. In this case, this is chlorine. Now listen. In this case, what? This 2 electron. But in this chlorine also what? This 2 electron. Right now, what will happen? The 2 electron transfer to this one. Complete electron transfer to this one. Okay, understand? This also 2 electron only. That's very simple, right? This bond is called a bridge bond. This is bridge one. This is bridge. Which center? This is 3 center, 4 electron bond. Very, very important. Please note. Okay. Now see. Now look the aluminium atom. What is the surrounding electron? 2, 4, 6, 8. Therefore, the central atom what? Obey octet. This is obey octet. Okay. Obey octet. Because surround 8 is also here 2, 2, right? 2, 4, 6, around what? 8 electron. This obey octet. Obey octet. Very important. Therefore, Al2Cl6, this is non-electron deficiency compound. Non-electron deficiency compound. Very important key point. But in case of B2H6C, look the B2H6 structure. See, this is a B2H6 structure. This is a B, right? Now see the boron atom. How many electron boron atom? Surrounded to 1, 2, 4, 5, 6. Only 6 electron, right? This also only 6 electron. Therefore, in B2H6, the B2H6, nothing but this is electron deficiency. This is electron deficiency molecule. But in case of Al2Cl6, the aluminum surrounding 8 electrons. Obey the octet is non-electron deficiency molecule. Understand? This is 8 electron because this is non-electron deficiency molecule. This is about what? The bonding about what? Al2Cl6. Okay. Now going to the comparison between the B2H6 and Al2Cl6 and next slide. The comparison is very important. The overall comparison. Please know the comparison. You make a box. Simple. Okay. Now. Very simple. Now. First point. This is B2H6. Here B2H6. Here Al2Cl6. First point, hybridization, both boron also sp3, aluminum also both are common, sp3 only. Okay, this is sp3. Right? Here sp3 only, sp3. And second, this incomplete octet because 6 electron. Incompleted octet. This is completed, right? Complete octet. Now this is electron deficiency because incompleted. Electron deficiency. This is non-electron deficiency. Non-electron deficiency. Understand? Now this is nothing but 3 center, 2 electron bond. This is 4 center, 3 center. This also 3 center, 4 electron bond. Okay. Now, which is more stable? Listen, always octet is more stable. Therefore, the thermal stability very important. the thermal stability of this two molecule, which is most stable always. Always octet is most stable. Therefore, the B2H6 is least stable compared to what? Al2Cl6. Okay, students, this is what complete about what the B2H6 and Al2Cl6. Okay, I hope you understand this class. Thank you so much for watching. Any doubt regarding the multi-cylinder bond, you can ask in comment section. And tata, bye bye, and see you in the studio as soon as possible.